bring it.
Welcome to NASA Edge's live coverage of the Cygnus launch from Hangar AE at Cape Canaveral Air Station in Florida. I'm Blair Allen, and I'm here with Mike Freilich, our first guest, and we're going to jump right in because Mike has come off console to talk with us this morning. Can you give us a brief update before we get started on what's going on with the Cygnus launch?
Sure. Things are fairly dynamic and evolving in time, but when I came out of the control room about 7 minutes ago or so, they were getting ready to start the engine on the plane. The weather is a little bit iffy, but all of the Pegasus, the plane, and the Cygnus systems are working well.
Awesome. Now, you're part of the Science Mission Directorate. What exactly is your role at headquarters?
So I'm the director of the Earth Science Division, one of the 4 major science divisions within Science Mission Directorate. We're in charge for NASA of all of the Earth-observing research satellites, the research and analysis program that takes the measurements and turns them into understanding, the applications program that turns the measurements and understanding into efficient data products for users, and technology development. So it's about 10% of the agency.
It seems like 100% a lot of work is what it sounds like. Well, listen, I'm wondering, when we think of Cygnus and what Cygnus is all about, how does that fit into the overarching goals of your office?
Yeah, it's a great question. As I mentioned, we fly a fleet of Earth-observing satellites. In order to understand the Earth as an integrated system, we have to make measurements of many different variables so that we understand not only individual processes, but the connections between the processes. We make those measurements from the vantage point of space with a couple of different kinds of programs, many different kinds of satellites. One part of the program are relatively large systematic missions, which are designed and optimized by NASA headquarters with input from the community. Cygnus is from a small, nimble, principal investigator-led, competitively selected, science-driven program of small satellites that are rapidly developed in order to complement the larger systematic missions.
Is that rapid development something that you're looking for, or are you open to, did it just apply in this case? Talk a little bit about that.
Rapid development is a key part of venture class and a key part of our endeavor because the science is evolving very quickly. Yesterday's science issue and challenge might actually be solved today. So rapid development where we can address the science issue of the day or of the half decade is critical, and that's what venture class allows us to do.
And it seems like a lot of these challenges that we're facing have to do with weather. And I know your background, you haven't always been a NASA headquarters person. You have a science background. So could you tell me a little bit about how you got involved in this whole process?
It's very, very interesting, actually. I'm an oceanographer by training, and my scientific passion was and is nearshore waves and how the water near the shore moves sand around. But soon after graduate school, I became interested in large-scale air-sea interaction, and in particular, the ability to use microwave instruments on satellites to see through the clouds, which are very often covering the ocean areas, in order to measure ocean surface wind speed and direction and other ocean surface variables. Cygnus is just the latest of those sorts of microwave measuring satellites, so that's highly innovative constellation. It will be making measurements of wind speeds in the developing eye walls, those tremendously dynamic regions of tropical storms and hurricanes.
Well, you have to be in a unique position then, because on the one hand, you're at NASA and sort of heading up this whole project, but from a scientist side, you've got to just be giddy about the kind of data that you're going to get from Cygnus once it's flying.
Absolutely. One of my biggest personal regrets is that sometimes being a bureaucrat, in fact, most of the time, being a bureaucrat keeps me from being a scientist. Our community is using the measurements from our satellites. They're developing new insights. They're publishing them, and I can't find the time to read the papers.
Well, now that's a good point. Now, speaking of I hope you find the time to read some of the papers. But thinking of that, the science that's going to come back from Cygnus, tell us a little bit about how that's going to help the scientific community, because that's a lot of what's motivating this whole effort.
Absolutely. Episodic events that are extreme, like tropical storms and hurricanes, are both symptoms of the environment and drivers of the environment. So being able to understand the processes that lead to the evolution of tropical storms and hurricanes, their intensification and their diminution over time, is really critical for understanding air-sea interaction, for understanding precipitation over the globe, and for protecting life and property. What Cygnus is particularly going to do is give us unique views of what is going on near the surface in the eye walls of hurricanes, where there's huge amounts of rain, and no other satellite or other measurement system can make accurate measurements there. Cygnus will be able to, and we will be able to use that insight in order to improve forecasts of not only hurricane track, but also hurricane intensity.
Okay, so does that also help you, not just to forecast it, but then you might better understand prediction, and you might better understand it well in advance what's going to happen with the storm because of this data?
Absolutely.
That's got to be exciting. Now, you'll be on console, like I said, very shortly. What kind of things are you going to be doing? Because, you know, as a bureaucrat, I know they're not going to let you, like, press the launch button. What kind of things are you going to be looking for, since you have that science background?
Well, today actually is focused on the engineering. Launch is an engineering operation. It's absolutely essential for the science, but the science doesn't get too involved in the launch. I'll be listening to 2 or 3 different communication networks all the time, keeping track of the aircraft systems, of the Pegasus rocket systems, and of the Cygnus payload itself, and of course, looking carefully at the weather.
Yeah, of course.
What I will not be doing is readjusting budgets.
Well, that's good, because, you know, the good news is if this flies successfully, though, you're one of the few folks that once that data comes in, not only can you help plan these missions and make them happen, but you can understand the data that comes in. That's quite a skill set you have there.
Well, thank you very much. My hope is to continue to be constantly challenged, both programmatically and intellectually, by what we're doing. And what we're doing is really exciting.
Awesome. Thanks so much for being on the show, Mike. I appreciate it.
Thank you. I really appreciate the opportunity.
Yeah.
Go Cygnus.
And when we come back, we're going to have our special guest co-host, Rachel Power. She's going to be interviewing John Shearer, who's the program manager for Southwest Research Institute.
I'm Rachel Power. I'm guest host, co-host for the NASA Edge podcast. I work with NASA's Digital Learning Network, and I have with me today John Shearer, who is the Cygnus Program Manager. Welcome, John.
Yeah, hi. How you doing?
Can you tell me a little bit about how Southwest Research Institute plays a role in this Cygnus mission?
Yeah, so Chris Ruff at the University of Michigan is the principal investigator, and way back even before the proposal went in, we were asked to join him and his team as an implementing organization. So we were responsible for building the spacecraft, integrating it to the deployment module, integration to the launch vehicle, and then mission operations, and then basically getting the signs to Michigan for the Science Operations Center for all the scientists.
So I think in just about an hour from now, hopefully, just about an hour from now.
If the weather holds,
If
that's
the
the big
weather
one right
holds,
now.
Stargazer will begin to taxi and get ready for takeoff with the Pegasus rocket on board. Can you tell me what you will be doing at that time?
Yeah, so right about 7:30 is wheels up, and then the drop is right around 8:30. This is Eastern time, and then 13 minutes after that is when we had the first separation of the first pair of the spacecraft. So as you get closer and closer to takeoff, things get very, very hectic. You know, we're kind of in a slow lull right now.
So right now you're here chatting with me, but you're not going to be here at that time. You're
No. I'll be on console.
On console.
Yeah,
Okay. Well,
yeah.
thank you for taking some time out of console to be here. Can you tell me a little bit about some of the unique features about this particular launch?
Well, I mean, a lot of different things. You know, this is an air launch, first off. It's a Pegasus launch. It's a rocket that's strapped on the bottom of an L-1011 airplane that gets up to 40,000 feet and then drops the rocket. So that part is very unique, and it's very much a man-in-the-loop launch. It's not your typical launch where you have a very scripted where things happen at a certain time. So, I mean, Adam is bouncing around all over the launch checklist, especially at the end, keeping a lot of things going, and then ultimately telling the pilots and the LPO to drop the rocket. So that part is unique. And then, the mission itself is very unique because we've got 8 small microsats. One of them, it'll fit on your desk. It's that small, about the size of a carry-on suitcase. And, all 8 of them, that we're going to be doing real science with these small spacecraft.
So you said that there's a lot going on right at that last few moments before launch. It's kind of like juggling a lot of balls at once. When you get to that point, you've been working on this mission for so long. How does it feel? Are you like looking at it like your child going off to college? Are you excited? Are you nervous? What's happening?
Yeah. I think it's all of those. I mean, very excited, obviously very nervous also. I've spent almost 5 years of my career doing this. Actually, it's kind of funny. My daughter's graduating from college next Sunday, and I started this before she started college.
Oh, wow.
So, yeah.
So this has been a long time. It's not your first mission, though, that you've worked on. You've got some history. Can you tell me a little bit about your background, how you got to where you are today?
So I'm a mechanical engineer by trade, and then got my MBA. And I've been in this industry now 30 plus years. Worked missions, Rosetta, New Horizons, LRO at the very beginning. Image was really my first mission that I worked at a mission level rather than an instrument level. New Horizons. IBEX, which is also a Pegasus launch. It launched out of Kwajalein out in the Pacific. I was a project manager for that also. So a very similar role in IBEX that I have on Cygnus. And then my last mission was MMS, which launched about 2 years ago, something like that, I think. And then came over onto Cygnus.
What has been the biggest challenge with the Cygnus mission thus far?
From my standpoint, I think it's that, Cygnus is part of the EVM ESSP program office, and it's a cost cap mission. And I remember from the very first day at the kickoff, Dr. Mike Freilich, who just was interviewed, I don't know how many times he said cost cap, cost cap, cost cap. So that was really the thing that was driven home on this particular. And I really, really appreciate these type of missions because I think NASA needs to do more of them. Trying to get everything done while staying in the cost cap and still meet requirements. I think that's a challenge on these type missions.
So once this rocket launches, hopefully today, fingers crossed, how much longer are you involved in this? Is the mission done for you at that point?
So, We launched today. Our first contact will be about 3 hours after the rocket launches. We should have contact with all of the spacecraft today. Then tomorrow I'm on a plane going to Boulder, which is where the Mission Operations Center is. And then for the next 2 months is basically our commissioning period. Nominally the first month is kind of working out all the spacecraft, make sure that all the spacecraft are healthy and work through that. And then after that we start bringing up the instrument and going through our CalVal, or calibration and validation period. And then it's pretty much in the hands of the science team, to get their data and do their analysis.
Now, I work with students all the time. That's my background. Can you give me a little bit of advice, words of advice you could give to middle school, high school students today that might be interested in working on missions at NASA in the future? What could they do to get involved?
Obviously, study your math, your science. I think if your high school or your middle school has a rocket club, I know the one that my daughters went to had a very interesting rocket club. I think that's always cool. Get involved with any kind of astronomy departments that are there. Just try and get out there and learn stuff.
Well, thank you, John. I know we need to let you get back to console. We're going to take another look at the Stargazer live on the tarmac, and when we get back, we're going to hear from Franklin, who will interview constellation scientist Aaron Ridley.
I'm joined today by Mr. Aaron Ridley, who is a constellation scientist from the University of Michigan. Good morning.
Good morning.
Exactly what is a constellation scientist, and how many constellation scientists are there in the world?
So a constellation scientist helps basically determine the orbits in a constellation mission such as Cygnus. And because there are not many constellation missions, there's actually only one constellation scientist in existence, and that's me.
Oh, you are the man.
Yes, I am the man.
You are the man. This mission, how did the University of Michigan get involved in NASA and Cygnus?
Yeah, so what happened was I was putting together a constellation mission a few years before Cygnus came along, and it was a proposal, and it didn't go anywhere. but a couple people at Southwest Research Institute found out about it. And so when this opportunity came up, the Earth Venture missions came up, they called me up and they said, hey, do you know anybody who knows anything about Earth science who wants to do a constellation mission? And I talked to Chris Ruff, and we got together and talked to Southwest Research Institute, and we wrote a proposal for Cygnus. Went from there.
So a constellation of satellites as they pertain to detecting the strength of cyclones.
Yes.
How does that work?
Okay, so the satellites themselves work by having reflections off of the ocean. So GPS is constantly sending out signals, and those signals reflect off of the ocean, and the satellites just receive those signals. And we basically look at the strength of the signal. If the ocean is very, very calm, the signal reflects off of the ocean really well, and it's a very, very strong signal. And so you know that there's not very much wind. But if there's a lot of wind, the seas are really rough, and the signal doesn't reflect off the ocean very well, so the signal goes down a lot. And so if we receive a very low signal, we know that there's very rough oceans and there's very strong winds. Now, the interesting thing about Cygnus is that there will be 8 satellites that are all along an orbit plane. And basically, if one satellite measures the eastern side of a hurricane, about 12 minutes later, the next satellite will come along, and the Earth will have rotated just a little bit, and so it will make a pass a little bit to the west of that hurricane. And then the next satellite will come along and make a pass just a little bit further to the west. And so it just keeps going through the hurricane and sampling and sampling and sampling and sampling. And that's very unique.
Now, how are these satellites arranged in orbit?
Okay, so the Pegasus rocket, which is going to take them up into orbit, is just one single rocket. And so the satellites basically are deployed from this single rocket. And then they're basically deployed away from each other with a speed of about 2 miles an hour. And so they drift apart at about 2 miles an hour. And if you just let them go, they would start lapping each other after a few months. And we don't want them to lap each other, because if you have 2 satellites that are right on top of each other, they're measuring the same spots on the Earth, and that's not very good. So we want them to measure unique spots on the Earth. And so we use this technique called differential drag to space them out. And the way that differential drag works is that you basically, Cygnus flies like this, and that's equivalent to like a tucked position for a biker.
Right.
And there's a little bit of air up there, and so all the satellites feel some air resistance. And so when they're in this position, they basically don't feel very much air resistance, but we can tilt them up, and that gives them a lot of air resistance, so they can slow down with respect to the other satellites, so we can control their speed using this differential drag.
And individually, you can control that and keep them at the right spacing that you need to
That's
get
exactly
the data
right.
that you need.
Yep.
Why the science? Why do it now?
Oh, that's a very good question. So classically, the last 10, 15 years, with lots of satellite data and lots of innovations, we have been able to improve our predictions of where hurricanes are going to make landfall. And so we know really well the track. But we don't do a very good job with the intensity of the hurricane. And so that's a crucial, important thing, because it's the intensity of the hurricane that causes the storm surge, and that's the thing that can hurt lots of people and cause lots of damage. And so the intensity is very, very important, but we haven't improved our forecast ability. And the reason is because we can't see the wind speed within the hurricane. And so Cygnus allows us to actually see through the rain in the hurricane and make those crucial measurements within the hurricane.
Now, for Cygnus, you're using these microsatellites. Can this technology and these satellites be upscaled?
By upscaled,
Can it be larger? Or is it the small microsatellites the best way to do this type of data collection?
so there are 2 key aspects to that question, I think. So the first is that these satellites are specifically designed for one instrument. That's what makes them so small. Usually NASA satellites have lots and lots of instruments. So you get lots of really good measurements at one location, and it orbits around the Earth in like 90 minutes. The Cygnus satellites have one instrument, and that makes them very, very small, so we can launch lots of them. So we get 8 measurements all around the Earth. So that's a very big difference in the way that normal satellites act. Now, the cool thing about this instrument is it's very, very small. So it only weighs like less than 5 pounds, and then there are some antennas that are really small. And so you could actually take this instrument and strap it on just a normal big satellite, and it would be almost nothing to the big satellite. So you could put this instrument on just about any satellite that's going up there.
Well, Aaron, that sounds really, really cool, and we look forward to seeing some of the data that comes back from Cygnus.
Yeah.
Thanks for being on the show today.
Thank you very much for having me.
All right now we're going to go to a video of the Senior Program Manager for the Stargazer, Mr. Ed Dunlap.
We're here with Ed Dunlap, who's the Senior Program Manager for Orbital ATK's L1011 Stargazer, and we're actually in the simulation facility here today. One of the things that we're wondering when we think about this operation of actually dropping a rocket from a plane and launching it into space is, what is the simulation process all about? What are your goals and objectives to get ready for that kind of event?
Yeah, no, it's a good question, and it is a complex operation because it is an air launch, so it's quite different than a standard ground-based launch. There's actually several aspects to getting ready for the launch. One aspect is the airplane itself. We've got to make sure that all of the maintenance program and requirements on the aircraft are met and up to date. And then for every launch, there's usually specific customized modifications. So we work with the Pegasus team of engineers in Dulles, in Chandler, and at Vandenberg to go ahead and make sure that those modifications are complete so that when we're ready to launch, it's all done. Another aspect of my job is to make sure that the flight crew is ready. And so that's what we're doing here in the simulation building. We're fortunate to have worked with a company here that has other simulators, and we have our own L1011 simulator. Like the airplane, this is the only other one operating in the world. But we're able to use that simulator not only to keep our crews current, but also to put in the launch profile that we'll use for each specific launch and allow the pilots the opportunity to actually practice that in the simulator before we go out and launch. And the third aspect of preparation for launch is facilities. In order to mate the rocket, we actually have to jack the aircraft. So we have some equipment that we have to send there and make sure that it's all ready and set up. And then we also have to set the facility up at, in this particular case, in Florida at Cape Canaveral. And that requires some coordination because of potentials of lightning strike there. So there's some specific things we have to do to make the ramp ready for the operation. So all of those things require a lot of advanced coordination to make sure that everything is set and ready.
Sure, and in a place like this today where you actually have a simulator, you go through, I guess like you said, the flight profile for Kennedy, even though you're here on the West Coast.
That's right.
You've got to be ready for any given circumstance for a launch.
That's correct, and that's the great thing about having the simulator is we can program in waypoints and coordinates for whatever location, simulate we're in that location, and the pilots can fly it just as if they're in that location.
How do you progress through the ranks to become a pilot, or is even at the goal? What is the purpose of the simulation, and what really qualifies for now being flight ready for a Pegasus mission?
Well, because we do launch relatively infrequently, whenever we do go on a launch, we take extra crewmen because we want them to be in the cockpit. We have, we're fortunate enough the 1011 has a very large cockpit. There's a couple of extra jump seats or crew seats that are in there. And so they can go along and observe. So we never have anyone who goes along a launch that this is the first time they've been in the cockpit on one. All of our flight crew are highly experienced, captain qualified, no matter what seat they're in. We also have, again, this is an older legacy aircraft, so it has a third position we call a flight engineer. And they're also there as an extra set of eyes, part of the communication process for a launch. So all of them have been through this numerous times before they ever get into the front seat to do a launch. Most of our guys came, obviously, if you've got a lot of hours in an airplane like this, it's usually because you work for the airlines. And so most of our guys came from the airlines, but we do have some that worked for Lockheed originally, that were production test pilots. Fortunately, with the simulator, we could bring in someone who may have been qualified on another airline type, large aircraft, and get them up to speed on our aircraft. And again, the simulator really allows for that because obviously the cost of operating the simulator versus the cost of flying an airplane that was designed to carry 300 people,
Sure.
uses a lot of fuel. So this is an excellent tool.
So for this simulator, did you have to construct it uniquely for the purposes of Stargazer, or how does that work?
Well, simulators were designed for primarily airlines to use to keep their flight crews current. And for many years, we rented space from TWA or Delta, who had those. When those airlines quit using the airplane, we were able to obtain a simulator from them. So it's really an airline simulator. The good part is that this particular one is in the same configuration as our L-1011. There were various types of L-1011, some designed for long range, shorter fuselages and things like that help them with long range. This one's exactly like ours. So from a performance standpoint, it's very similar. In terms of preparing for Pegasus, we haven't really made any changes to it. There are some things that we might be able to do and that we're looking into doing, but none of them are really substantive that would really help the crew any more than just being able to use it to practice the launch.
Ed and the folks at Orbital ATK were absolutely fantastic when we went out to check out the simulator. But listen, Rachel, I think we need to stop now and help clarify a few things, because the original launch time, when I woke up this morning at, I don't even remember what time I woke up this morning. Exactly. But the original launch time was 8:24, but it's moved to 8:30, and this is all weather related. They're dealing with weather issues for the launch, but that could still change. And
That's the beauty of it. Everything is up in the air. We're all excited about it, literally.
and not up in the air yet.
Not yet, but in about an hour it will be.
Yeah, in about an hour it'll be up in the air, and as you saw, Ed and the team will be faithfully flying the Stargazer L-1011.
I was a little bit jealous, I have to say, watching that video. Did you actually get to fly the simulator?
No, it's funny. All the warranty stickers came on, and they just were like, "This is a beautiful simulator. It's nice for you to look at." But I think when I started asking questions, they realized just not the best for the equipment. Yeah, I would have had a good time, but I don't think the simulator would have survived. So it's one of those tricky things you deal with. But it's still really cool to think that today we're out there with the pilots that are going to be flying today, and that they're still training pilots, guys getting ready to do more launches in the future. So it's kind of cool.
Yeah, in fact, we had the opportunity. You guys got to go out and meet some of the folks that are working on this mission. Franklin, in fact, got to interview the payload launch panel operator. We're going to take a look at that video now.
So Fred, we're sitting on the L-1011 here at Vandenberg Air Force Base. There's the actual plane that carries the Pegasus rocket. Now, you wear several hats as far as integration and working with Orbital ATK is concerned.
Right.
Tell us exactly what you do in your job with putting the satellite and the rocket together.
So after we've done the electrical interface testing with the satellite and the mechanical interface testing, I work with a team of electrical and mechanical engineers and technicians. We work with the mission engineer who designed the interface, and then the program specialists who are avionics specialists to put it all together and close the fairing up. We coordinate the operations to bring the vehicle out to the L-1011, and then the L-1011 will literally fly in 2 days before mate, and we'll raise the rocket up onto the hooks of the L-1011. All of that happens very short schedule in order to make the launch date. There's very little delay.
Is there any additional work that has to be done when you work with a satellite like Cygnus that has so many parts to it?
Well, one of the things that's interesting for Cygnus is that they're obviously very sensitive to GPS signals. The science of the satellite uses that. So we're able to provide them our GPS repeater in the facility. They're able to test the spacecraft independent of the rocket with that repeater. And then once we come together, we'll have verified our function of our vehicle, they'll have verified the function of the spacecraft, and then we'll do it as a coordinated test. Providing them the RERAD is unique to the spacecraft.
Now, speaking of unique, we're actually on a unique but old airplane, the L-1011.
Right.
Tell me a little bit about the upgrades that were made to this aircraft to get to where it is now.
So there was both electrical and mechanical changes to the aircraft. Interestingly enough, the original frame of the aircraft was perfectly suited for Pegasus because it has a dual spar configuration along the base, and they were able to cut a box out at the bottom of the airplane to allow the rudder to rest up inside the aircraft. It's kind of an unusual aircraft configuration to allow that. There were several changes to both allow electrical control of the rocket, to provide air conditioning, and to provide nitrogen. which a lot of our clean spacecraft require. These modifications went on for many years before the aircraft was ready for testing with Pegasus.
Now, when we get to launch time, you go from being an engineer, electrical engineer doing integration.
Right.
Talk to me about your position on the plane when it's time for launch.
Yeah, so there's 3 launch panel operators. Jim Stowers is the senior launch panel operator, and he is the one who's responsible to control the vehicle, configure it for launch. I'm the payload launch panel operator, and I'm configuring the satellite for launch. We take training and instruction from the payloader to make sure that the way we configure it prepares it so that it's in the right configuration for launch. And then Jim Keeney is responsible for controlling the environmental control system of the payload. All of this we do in concert with a team of engineers in a launch control room who are monitoring telemetry from the rocket continuously to make sure that all the state changes are as expected.
If there was one thing that you could let everybody know about the process of launching the Pegasus rocket from the L-1011 that they might not know, what would that be?
So unlike most launch vehicles, you have to count down towards your T0. You have to make sure that all the systems are within the thermal constraints. You have to make sure that all your batteries are sufficiently charged, and everything is counting down towards that T0. And a lot of that is done with an automated system, which does the checks and allows you to continue. With Pegasus, our launch pad is moving through space, literally, so we can be high of our launch point, low of our launch point, right, left, or we can be late and early based on headwinds and tailwinds, or a late taxi. So we have to make sure, in coordination with the flight crew, in coordination with the launch engineers at the control room, that the airplane and the rocket are at the right point in space, at the right speed, with the right temperatures, with the right batteries, and all of that's done manually because it really can't be automated. So it makes for a very exciting T0, and we really hustle to make everything come together.
That sounds like a lot of moons need to be aligned.
Right, it's a lot of moving parts.
A lot of moving parts.
Yeah, yeah, which makes it really fun.
Rachel, Fred knew the stargazer like the back of his hand. That was a very interesting interview.
It seems like you learned quite a bit, and I understand you actually got to fly on board the Stargazer.
Well, actually, the video that you saw in the package we just ran, that was from our trip. They had some pretty nice seating in there. You saw a couple first-class seats, but we were able to see the pilots the way they worked in the cockpit during the simulation of a run, in addition to seeing the launch panel operators in the back at the console, what they do during a launch like today.
So what does it feel like to fly inside of an aircraft that's now about to carry a rocket?
Well, it actually felt just like flying on a regular passenger aircraft. When we got up to altitude, we were able to get up and walk around, and I didn't actually feel anything different from what they would feel, what you would feel if you were on a passenger aircraft. But from what I understand, that there is a bit of a difference, and you feel it when the actual Pegasus rocket is released. But we didn't get the chance to feel that.
You didn't get to ride shotgun on this flight?
No, didn't ride shotgun. Walked up into the entrance of the cockpit, saw the pilots as they, worked with one another inside of the cockpit, and it was just very interesting to see the dynamic that goes on between the pilots and the launch panel operators in the back. So it was a cool experience.
So I understand the guys in the cockpit, they're all certified captains, whether they're sitting in the captain's seat or the flight engineer seat or wherever they might be.
Well, earlier we had the package from Ed Dunlap with the flight simulators. They go through flight simulator training, and before they're able to get into the airplane. But that brings us to our next interview, which was with Mr. Don Walter, who is one of the 2 pilots that are flying the Stargazer today for this launch. Let's check it out.
So Don, you're a pilot for the L-1011 Stargazer, and you're actually flying the Cygnus mission, is that correct?
That's correct. I'm the pilot for the Cygnus mission, but I'm supported by a lot of people.
So how many of these missions, these Pegasus missions, have you flown on, or have you been a pilot on?
I've been the captain on the past 2 missions. I flew 2 as a co-pilot and 1 or 2 as an observer prior to the Cygnus mission.
So tell us a little bit about what happens from your standpoint to fly up and get in position and actually launch a Pegasus rocket.
Well, it's pretty exciting to start with. The successful launch is basically a lot of normal procedures planning and a lot of planning for any of the contingencies that can happen prior to the launch. We spend a lot of time flight planning on the ground. Day of the mission, we load actual conditions for Cape Canaveral or down on the equator, wherever we are. And from the time when the aircraft actually starts rolling down the runway, it's a fairly scripted procedure. So someone in orbital, the scientists, calculate exactly the time when the Earth will be in the correct position for us to launch. And my job is to have the airplane at the right altitude, at the right speed, at the right heading, at the right time. So occasionally the launch windows can vary from as short as 5 minutes, where we have to have the airplane exactly at the launch point with plus or minus the 5 minutes. On the Cygnus launch, we have a 2-hour window, which gives us a unique opportunity to fly the pattern twice if we need to.
What are the kinds of things that can happen once you're aloft that may actually cause you to not be able to launch on that first attempt?
Okay, so there is a very detailed checklist that we proceed through from actually hours before we leave the runway, even before we start engines, until the time when we launch. And there's a very long script that involves all the players. We have launch parameters for weather, for the aircraft, for the rocket, for the range. And there are systems, people monitoring all of those systems on a real-time basis. So when a problem occurs, and it may, that exceeds one of our launch parameters, if it's an aircraft-related issue, it's up to me and to the launch conductor to determine whether it will affect the safety of the launch or the effectiveness of the launch. If it's something to do with the satellite or the rocket itself, then it's up to the launch conductor to tell us launch or don't launch.
Now, do you go through those parameters in the simulator as well?
We go through the parameters that affect us and the flight of the aircraft. So, for example, as we get toward the last 4 minutes of the clock are critical for us, and there's a lot of things that happen in sequence on a script, and if one of those things doesn't happen and the launch is aborted, okay, we go through a securing the rocket checklist to make sure that everything is safe. And then on the ground, they'll make a decision. Is the problem resolvable? Can they look at the constraint and see, given enough time, can we work around it? In which case, we'll come back around again and attempt one more launch. Or if it's a problem that has occurred that they need to do some maintenance on the ground, we just bring the rocket back.
Now, when you're flying the plane, it's a big plane and you've got this super huge rocket underneath. What happens once separation occurs? Because I imagine, part of you wants to see the launch, but another part of you needs to maybe get to a safer area. Tell us about that.
Well, that's true. And so in aviation, we have a rule that no matter how interesting something is, somebody always flies the airplane, in which case it's me. The laws of physics work in an interesting way. It's not very often that an airplane releases 52,000 pounds all at once. So the forces that work on an airplane in flight at the moment we're releasing the airplane is lift and gravity. So what happens is the lift overcomes the gravity. We weigh a lot less, so we go up and the rocket starts falling down and we separate by several thousand feet. The rocket will free fall for 5 to 7 seconds before it actually lights off. And as long as its safety parameters are met, the rocket lights off, and it's pretty exciting to watch it accelerate out ahead of us and then climb up into space.
We're back on the set, and I'm joined right now by Mr. Justin Treptow from LSP. Good morning.
Good morning.
Justin, you're here today to give us a demonstration of an app, but before we get to that, tell us a little bit about what you do at LSP.
Absolutely, Franklin. So my job at LSP is a flight design engineer, which means that I work with the trajectories that the rockets fly on, specifically making sure that the spacecraft can get from the launch pad to its operational science orbit with all of the requirements met on time and in good order.
you do that for your regular job, but then you got involved with Spacecraft 3D, which is the app that we have on set today. Tell us a little bit about that.
Absolutely. Spacecraft 3D has been out in the world for a couple of years now. It started out as a project from the Jet Propulsion Laboratory, JPL, and before LSP got involved, it was mainly just spacecraft, mainly rovers from Mars. I know they had done some stuff with National Geographic to highlight the different exploration projects NASA has been on. But about a year and a half ago, 2 years, I was playing with it at my desk, and I was really geeking out at how cool this was, that you could use an augmented reality card and see a spacecraft sitting in your hand and move it around as if it was something physical that you could interact with. And all of a sudden I had the idea, like, we should have rockets in this. This should really be something that LSP is getting involved with. So I just made an email. I made an email to the guys at JPL and said, hey, what would it take for us to get involved and have rockets included on here? And it was really a case where my program kind of empowered me and our outreach group to go and make this happen.
Now, Spacecraft 3D is available where? Where can people find it?
That's a great question. Spacecraft 3D is an app that you can download for iOS or Android, both on a tablet or a phone. The experiences of using it are a little bit different. When you have a tablet in hand, it's a lot easier to move the tablet around a target you might have on a table. But when you have it on a phone, it's very portable, and you can move the phone around, and it's two different ways of experiencing it. One feels like a magnifying glass, the other one feels like you're holding the model in your hand.
Now, today we were supposed to have a demonstration, but right now we can't get the app online right now. But I do want to show everybody here, let me grab this, the target that is used for the app to work, and you actually have a smaller version that's on a card.
Yeah, absolutely. This card is great for wallet size. One side will have an image of a spacecraft or a rocket, and the other side has a smaller version of the augmented reality target that you have in your hand.
Now we have Blair, you can see in our two-shot, is over here trying to get this app up online. Oh yes, we can see you. Yes, we can. This is really cool because we had this set up on our table here, and when you point the app toward this target, one of the first things we saw was the Curiosity rover popped up. And you're able to turn it around, move the arms and levers on the Curiosity. Okay, I hear that we have the app online here. Can we see this here? Let me put this back here. Okay, let's go to the app. There we go. There we go.
I'll take this.
Okay, in a short period of time we have left, go tell us what we have here.
So what we're looking at is a screenshot of the app running Spacecraft 3D, and specifically we're looking at the Pegasus launch vehicle on top of the table. Because it's a really large augmented reality card, we get a really large spacecraft attached to the L1011. Which the cool thing about this app is that you can move through the different stages of a mission. So when we have the Pegasus launching today, we have the first configuration from when we're on the tarmac, but as we go into the air, the Pegasus gets dropped off the L1011, which we can step through. You see the Pegasus drops below.
That's awesome.
Then we can move through the first stage separation.
Oh, we didn't see that earlier.
The payload fairing separation, revealing the spacecraft inside. And this is not the Cygnus mission. This was an earlier one, but you still get a really good idea. And then the second stage drops away, and you get third stage. And what is really useful about seeing the spacecraft and the launch vehicles is you get a great scale of how small the spacecraft is relative to how large the rocket is at the beginning. And that's not something that you can really intuit without seeing the entire mission sequence going all the way through.
Oh, Justin.
Do it again. That's awesome.
Yeah, Justin, that is awesome.
Through it.
Okay.
And
That's awesome.
it should work even smaller on a small card, the one you might have in your pocket. There we go.
Oh, yeah. Oh, nice.
A little bit smaller version, and it just scales relative to the size of that card. You can blast it up, you can bring it back down, you can take pictures of it in your hand. It's really a fun thing to play with and get an idea of how big and what these spacecraft look like. So when you hold it in your hand, you can move it around and really get
that's cool.
a good idea of what this looks like from all different angles.
Oh, that is
Justin,
awesome.
that is Blair, when we were doing this ourselves, we didn't get this type of view. This is nice.
Get it to work for the demonstration.
Yeah, that was the co-host version. The set therapist said. Hey, Justin, thanks for coming on today. We really appreciate your demo of the app, and hopefully we can get some more spacecraft and vehicles on that soon.
Absolutely. Just go down to the App Store, iOS or Android, and download Spacecraft 3D for your tablet or phone.
All right, thanks a lot, Justin.
Thank you, Franklin.
Next, we have Mick Waltman, who's going to give us the 411 on the integration of the Cygnus satellites with the Pegasus rocket and the Stargazer aircraft.
So Mick, ordinarily you're on our show during the live webcast and talking us through some of the processing of the spacecraft, but this time you're not on our live show because you have a different role for this mission. Tell us what it is.
Yeah, for this mission I'm going to be serving as a vehicle systems engineer, leading the LSP engineering team. We'll be processing the vehicle, looking at the vehicle during flight, making sure everything's ready to go so we can give the NASA launch manager a go for flight when it's time.
Will you actually be on console?
We'll actually be on console, leading that team, conversing with the team and getting all our feedback so we can provide that up to the management chain and the launch director for ready to go.
Awesome. Now, I understand that this is a unique mission, obviously, but tell us a little bit from Launch Services perspective. What is processing of this kind of rocket? What's involved in that process?
So yeah, unique air launcher that Orbital ATK provides. One of the things that's great for us in Launch Services program is we actually work on both coasts of the United States. The vehicle's processed in Vandenberg Air Force Station, so we do a lot of our work out there in flight sims and testing, and then we ferry the vehicle back here to the Cape for final processing and getting ready for launch day. Once we get the vehicle here to the Cape, we'll do some final testing, what we call combined systems test, to verify everything is ready to go for the day of launch. On ferry day from Vandenberg to the Cape, the Launch Service Program will have a team in Vandenberg looking at all the data as we fly out over the horizon, making sure the vehicle is in a good health status, and the computer and the SIGI, which is our inertial navigation unit.
SIGI, I hadn't heard that before. Okay.
SIGI, inertial nav unit, is in good processing, ready to go. And then we'll also have a team here at the Cape for when we fly the vehicle in. And we will actually fly through the area of the Cape to make sure everything's good and that we're picking up our signals with the range assets here on the Cape side, and we'll verify that health status again with the inertial nav unit and the flight computer prior to landing and getting ready for our final testing before launch day.
So from a launch services perspective, what goes into deciding that you're actually going to use a Pegasus rocket for a particular mission?
As we've talked on your show before, Launch Service Program has a wide variety of fleets to choose from. Pegasus is what we call our small class vehicle.
My class.
Yeah, your class. That gives us an opportunity to work with universities and smaller satellites for science opportunities. Cygnus is actually launching here out of the Cape, which is we're very happy about, but it's the first time that we've launched a Pegasus out of the Cape in 13 years since the Galax mission, which Launch Services Program was part of. And we're very excited for that. Matter of fact, our next mission is the ICON mission, and we'll be taking the Pegasus system to the Kwajalein Atoll to launch that in 2017. So we're very excited to be partnering with Orbital ATK and the Pegasus system again.
That's awesome. I'm sure it'll be a successful launch.
We are looking forward to it.
Normally, Mick Waltman is actually on our show, but he's supposed to be on console. But as you can see now, where Tiffany is standing there in the back next to the empty chair, that's where Mick Waltman's supposed to be. He can't be on our show, but the chair is empty. So we're going to put out a little notice looking for Mick Waltman and see if we can find out what's going on with him. But glad he at least gave us an interview and
Yes.
gave us the basic information about.
And he actually ran on our set earlier this morning. I was hoping to grab a word with him, but his phone rang and he was out.
Well, you know what? I tell you what, Franklin, I'm very excited because I think we're about to get some behind-the-scenes footage. I think we have in-plane footage from the L-1011. Let's check it out.
NASA 3.14159, you're cleared for takeoff.
NASA Pi, roger.
Huh? Contact departure control.
Roger.
Huh?
Request vector clearance, over.
What?
Your vector is 270.
We have clearance.
Roger, roger. What's our vector, Victor?
Tower radio clearance, over.
That's clearance, over. Over.
Roger.
Huh?
Roger, over.
What?
Huh? Who?
Okay, clearly we went to the wrong footage there. That's not actually live from the L1011.
That was a little skit that we shot in October when we were out in California. But the guys, the pilots and the payload operators there, they played along. They were
Yeah,
great.
they're very enthusiastic about taking part. But listen, I tell you what, we're about ready to end our show, or our part of the live coverage for the Cygnus launch today. Following our show, George Diller is going to provide NASA commentary from KSC TV, and it's going to take you right up through the launch. But I tell you, we love working with George. George is great. But I tell you, what you're normally used to seeing during the commentary show is not always what you see behind the scenes at NASA. So let's take a look at that real quick.
Here, you want a cue?
George, 30 seconds away.
Are you kidding me?
Wait, what's George doing?
It's a countdown we're talking about. I've been
I
doing
know, it's weird. He's normally such a pro.
He's completely off script.
waste of time. The top all the way.
Yeah, here. Better take him this.
9 rocket launch, 8 rocket launch. I've been doing my own counting since I was 4.
George, here, eat this.
Better?
Let's do this.
Stand by, we're going live.
Go for terminal count. T-minus 10, 9, 8, 7.
Launch
6,
first,
5.
then launch.
Go for main engine start. 1, 0, and liftoff on a NASA mission to interstellar space.
George is a good sport.
He is a good sport. I'm so glad that he played along, and I tell you, very professional guy. Clearly, when he's eaten and everything's normal, he'll deliver every time. It's perfect.
And you saw that cake there in that shot. It is the 10th anniversary of NASA Edge, so everybody out there, if you're watching NASA Edge for the first time, make sure you look us up, download the podcast, and learn more about NASA.
Also, we're going to be coming back on Facebook Live at 8 a.m. All the way up through the launch. But until then, stick around. KSC is going to be providing excellent coverage, excellent commentary coverage, and they're going to have the PI on for Cygnus. They're going to have guests, and as always, George Diller, as long as he's fed, will provide excellent commentary coverage. You're watching NASA Edge.
An inside and outside look at all things NASA.